Before you get to the exciting stuff with electrofishing, let's talk about important component safety. Today we're going to be talking about the safety features of your gear, safe operating procedures, and personal protective gear. So stick with us. Now we're going to talk about the safety attributes of the construction of an electrofishing boat. All electrofishing boats have to have a power source, a generator. The generator generates the power that goes into the control box, and the control box is where you can change the waveform attributes, control the amount of voltage you put into the water. The control box hopefully also has instrumentation, metering, so you know what you're putting out into the water. The power from the control box goes into the interconnection system, the wires and conduit, where it goes then to the electrodes. And typically it's the hull is one of the electrodes and the booms are the other electrodes. So if you're electrofishing with pulse direct current, the hull would be the cathode and the booms are the anodes. So we have the generator that generates the electricity, then it goes directly from there to the control box. And at the control box you can select waveforms, AC, DC, that sort of thing. But the most important thing on the control box for a safety perspective is the metering, so we know that electricity is actually going out into the water, and a shutdown switch, emergency shutdown switch. So this is a slap switch type of switch, and important because if something happens and you're in the driver's seat, you can reach down, slap it, and the electricity is cut off at that point. So for Fish and Wildlife Service policy, it's just required that we have one safety pedal up in front and the driver have control of the generator, and this is it right at that spot. Then the waveform that you select from the control box goes out from the control box into the interconnection system, the wires, to be delivered to the electrodes. We'll take a look at this at the interconnection system. Okay, from the control box, the electricity passes down conductors, wires, and the wires need to be a particular gauge to handle the amperage that you expect your unit to generate. So typically 14 AWG, American wire gauge, to 9 AWG is used. The insulation is rated for voltage, and we run the wires in flexible watertight conduit. And here's a piece that it's just very flexible. It's easy to attach to the side of the boat and run wires through. And we use the flexible conduit so that the conductors, the wires, are protected from abrasion, from the weather, and that sort of thing. It's just a safer, drier environment for the electricity to be in. Any splices in the wires need to be made inside watertight conduits. So in this case, we have the anodic line coming through, and we have a splice in the wire here to have a branch line going out here to one boom. And we use a wire nut inside a conduit. When you run your wires outside of your conduit, it needs to be in a cable. And this is an example of the line going to this boom. When you're traveling, the boom is retracted back for traveling, and when you're electrofishing, the boom is pushed forward. So you need to disconnect the boom. When you disconnect or connect the boom to the system, these watertight twist lock plugs are just really a good safety feature to have. Keeps the water away from your circuitry. Most safety policies, including the Fish and Wildlife Service, require that there's a safety switch for the netters up in front, so that if someone falls out of the front, that the electricity is stopped before they hit the water. Typically, mostly these are in the form of a foot switch that when pressed down, the electricity is on, delivered to the electrodes, and when the foot comes off, it shuts off. The circuitry on a foot switch is 24 volts only. It doesn't break the main line, the high voltage line directly. It trips a relay back in the control box to turn the electricity on and off. The rails are an important item. Most boats have them. Rarely do you see hard-hulled boats without rails, but typically they need to be at least waist high to slightly higher than your waist. In rafts, it's a good idea also to have railing. In many of the rafts, the railing is short, but you kneel down in front. Once in a while you see a raft with waist-high railing, but most is short, so you can kneel down. But it's a good idea always to have railing. The boom line comes out in a cable and through the boom. And the boom material typically is fiberglass or PVC, but some non-conductive surface to keep the anodic line and the cathode separate. Having booms fixed in place on metal-hulled boats is a must. You don't want a movable anode on a metal-hulled boat, because if the electrode touched somebody inside the boat, you'd be bridging two different electrodes and completing a circuit. Movable anodes are used in some situations. However, the boat hull is non-conductive and the cathode electrode is usually a plate underneath the hull, out of reach. Keep in mind that you're not only concerned about your crew safety, but also the public safety as well. And the Fish and Wildlife Service safety policy that you're required to shut down operation if the public approaches within 100 feet or 30 meters of your gear. Putting signs on your boat to warn of electrofishing and the danger of electrofishing is a good practice. Boat electrofishing is a little bit unique in that the crew is isolated from the electrical field in the water. Most boat hulls are wired as the cathode, and so you're standing on an electrode. You're somewhat like, in boat electrofishing, you're somewhat like a bird on the wire. You can be raised, the bird can be raised to 20,000 volts and is fine, unless the bird also touches a conductor or something else of a different potential. And when you bridge two different voltage potentials, you complete a circuit and you can get shocked. So in a boat situation, you want every significant piece of metal, like the generator case, referenced together so that there's no potential differences between them. To test if the various pieces of metal on the boat are in continuity or electrically connected, you use a multimeter. You set it to ohms. And what you're looking for is when you touch pieces of metal, between two pieces of metal, what you're looking for is a resistance something less than an ohm. Now, a lot of these units will beep if the resistance is less than 1 ohm. So right now there's no beep because there's no connection electrically, but when I bring these two probes together, they beep because there's low resistance now, less than an ohm. So if we look at the hull here and we find two places on the hull not covered by paint, you can see that obviously there's less than an ohm difference between those two places on the hull. So now we want to check the metal surfaces around the boat. And the first one we'll start with is the generator. And so we'll put one probe on the frame of the generator where there's not paint, and then the other probe to the hull. Sometimes you have to feel around a little bit, work the probe in a little bit, but what that is saying is that there is less than 1 ohm difference of resistance between the hull and the frame. So if there was a short to the case of this generator and this generator, the voltage potential is elevated, then the voltage potential of the hull would be elevated. They'd be the same thing. And so if you put your hand on this, on the generator case, and the hand on the hull, you wouldn't get shocked. So we can do the same thing then with the pulsator. The pulsator is also in continuity with the hull, electrically connected to the hull. In this particular system, the pulsator is connected to the hull through the generator. And anything that generates its own charge, the pulsator there, the generator, we want hardwired to the hull. Other pieces of metal that might be in this boat in particular, the only thing we'll check maybe are the rails, but the major things in a boat are the generator and the pulsator. Yeah, for other pieces of metal in the boat also need to be in continuity with the hull. This is a live well that is non-conductive, it's made out of non-conductive material. We don't have to worry about it, but often they are metal. And if they're metal, they also need to be checked with a multimeter to see if they're in continuity, to see if the live well's in continuity with the hull. The connection can be passive. That means it would just sit on the hull. In this particular case, if this live well was metal, it would be sitting on a non-conductive surface as plywood, so it would be isolated from the hull. And in situations like that, you need to run a ground wire, a wire from the metal hull, the metal live well to the metal hull. This is a tow barge electrofishing unit. It's similar to a boat, except that no one is actually in the barge. It has a generator, power source, the control box, a live well. It's operated in shallow water. There's an operator in the rear that controls the barge, and then you have one up to or two or three anode poles that go out simultaneously. The hull on a tow barge needs to be non-conductive, and we'll talk about that in a second. The cathode is a plate that is underneath the boat, isolated from the anodes. So basically, safety-wise, there's a couple things that need to be paid attention to. You want just as in a boat, you want the generator and the control box to be in electrical continuity. So if we take out our trusty ohm meter, turn it to ohms, and then put one probe on the metal frame of the generator and the other one on the metal frame of the control box, it beeps. It's less than 1 ohm, so they're in electrical continuity. That way, if there's a short to the case here, that you won't get a shock if you have a hand on each. For safety switches, basically each anode pole has a safety switch, just like with the backpack unit, and those safety switches have to be depressed simultaneously. In this particular unit, the operator does not have a safety switch, but you can incorporate a safety switch for the operator. The reason why the generator and the control box were in electrical continuity is because in this particular model, the hardwire connection between these two pieces of equipment is made through the generator power input to the control box. Other models do not have that connection, so you'll have to put a hardwire connection between the control box and the generator to make sure that these two units are in electrical continuity. Test it often with an ohm meter. We're going to talk about the safety features of backpack electrofishing units using two different models. On this particular model, there's an on-off switch, so the operator can reach back, turn it on. That readies the unit. Then there's a safety switch on the anode handle, and when the safety switch is depressed, the electricity flows, the circuit is closed, and you're fishing. There's a reed switch, something called a reed switch in here that can break, so you need to be somewhat careful with these anode poles. So once you're electrofishing, then the unit tells you and the people on the team that electricity is going into the water in a couple ways. An audio way, there's an annunciator that beeps inside, beep, 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 and you can control the volume here. And a visual way, the light comes on here and lets you know that the electricity is flowing. Also, of course, it has good metering with electrical output. Now, as far as some of the other safety features of the unit, there is a tilt switch, internal tilt switch. So if you go too far forward, the unit assumes you're falling over and it shuts off. And then you have to stand back up straight and then take your finger off the safety switch on the anode pole and re-engage to get it started again. So forward, oftentimes 50 degrees forward, side to side, it'll tilt 45 degrees often, and then backwards 40 degrees. So the unit is sensing that you're falling and will shut off. Now if there's a vertical fall, so if you're walking along with the unit and you fall vertically, there's a water immersion sensor, and that is this object here. And if water contacts the immersion sensor, then the equipment shuts off at that point. Backpack straps on these units differ somewhat. On this particular electrofishing unit, it does have a quick release belt buckle that you can disengage quickly if you become submerged. And a good thing to do is with your wader belt buckle to move your wader belt buckle behind you so that if you do have to quickly get out of your unit and disengage this quick release, that when you reach down there's no confusion. That's the only belt buckle that's available to you there. It's a good idea though that since these do differ between units somewhat, that you know your backpack straps, how to get it in and out quickly, particularly out. This unit has similar safety features as the previous one we looked at, but the safety features are a little bit differently configured. So let's take a look first at the on-off switch. The on-off switch is a mushroom slap switch type of form where you turn it, it's on, and then if there's an issue where the unit needs to be turned off quickly, it's just a slap and easily turned off. The light that on this unit, the blinking light to warn that the unit is engaged, the power's on, is larger here, this unit, and it blinks. This model also has a splash-proof cover. The battery's inside, and it has a splash-proof cover to keep the water away from the battery. The straps are a little bit different. Like the previous model, it has a quick-release belt buckle, but it also has quick-release shoulder straps as well, so it helps to get out of the unit should you be submerged. A final safety feature on these units that are optional in many of them is something called the anode out of water safety switch. What that does is if the anode comes out of the water and you still have the safety switch on the handle engaged, the machine will note low current and shut off. So you can't then touch somebody with a live anode even though you have the safety switch engaged. This is not, though, a safety backup for netted anodes, for a procedure using netted anodes. Just a quick mention about dip nets. For electrofishing, you want non-conductive handles. You want handles made out of non-conductive material. Formerly, a lot of times these dip nets have metal handles and they'd be electrified, and the dip netters would get shocks on their upper arms where their gloves didn't touch. So non-conductive material for your handles. Regarding personal protective gear, gloves are of critical importance for keeping people safe from being shocked. Many safety policies require linesman's gloves, and this is a set of linesman's gloves that are class 0. They protect up to 1,000 volts. But linesman's gloves are made to be used in the dry and made to be used with a protective leather over glove. Oftentimes, though, they're not used with a protective over glove. In fact, about all the time they're not in fisheries work. And they're very smooth surfaces, and they're cumbersome. They're hard to hold objects in because they are slick. And they also can lose their rating very fast due to micro punctures due to fish spines and that sort of thing. Instead, the Fish and Wildlife Service safety policy just requires rubber synthetic gloves. And most of these gloves are made for use with solvents. And so they have channeled or roughened surfaces and so they're made for use in wet environments. So they're great for electrofishing, holding fish, holding slippery dip nets, etc. And they definitely, although they're not electrically rated, they're definitely sufficient to keep you from being shocked. The only time you're going to run into high voltages is when you have both electrodes in your hand simultaneously, the anode and the cathode, and you never want to do that with the power on. For personal flotation devices, PFDs, on boats, typically we use a type 3 PFD, which is a vest type. They're comfortable, lightweight. In some circumstances, people will use type 1 or type 2 PFD, a little heavier, but will turn an unconscious person over, face up. In backpack electrofishing or shore-based electrofishing, or just wading electrofishing, we don't require, Fish and Wildlife Service does not require PFDs, but you can, as an added measure of safety, wear a suspender type auto-inflating PFD that is lightweight and comfortable. The next item is waders. Waders not electrically rated. You may get a shock with breathable waders, so we recommend a minimum of lightweight waders. On boats, shin-high rubber boots are sufficient. For those of you around generators and electrofishing, have your system tested for noise levels and refer to the Fish and Wildlife Service safety policy for OSHA standards. If your noise levels exceed those standards, then hearing protection is required.